Today's lecture is on weights and measures, and a little bit later in this lecture we're also going to be discussing knife skills. So we're going to be talking a lot about how to measure ingredients, and this lecture may seem a little bit strange to those of you who cook in your own kitchens, and the way that we're going to talk about measuring is maybe a little bit tedious, maybe sort of overkill. And the way that we're going to talk about measuring out ingredients for the home cook probably is overkill. So I want to make that distinction right now. Where it does make a difference is in commercial food preparation, and to some degree in baking, and we're going to talk about that more as we go on through this lecture and also through the course. But the main reason to make sure that you're measuring foods correctly, measuring your ingredients correctly when you're cooking, is that every time you make something, you come up with a fairly uniform ingredient. If you're really careless with your measuring, every time you make something, it's going to taste a little bit different. And that may or may not be a big deal to you at home. But if you go to a restaurant and things are prepared sort of inconsistently, it really can affect your opinion of that restaurant or that food service operation. So, and you may have had the experience where you've gone to a restaurant one time and the food was amazing, and you went again and you ordered the same thing and it just wasn't that good. And as we're going to see through the entire course, because I'm going to be talking about it a lot, that technique makes a big difference. It's really, really important. And an important part of that technique is accurate measuring. So standardized measuring is what we're talking about, meaning that anybody who's making a recipe follows the same manner of measuring foods out over and over and over again. And in commercial food service, that's also important for controlling your food budget. If you have somebody who doesn't know how to measure out properly, they could be using too much product or not enough product, and then you get a lot of inconsistencies, and ultimately you waste money on ingredients that didn't really need to be used. I want to differentiate between weight and volume measures, because when we're cooking we use both dry and wet ingredients, and weight and volume are the differences in those types of measures. As you see on the slide here, volume measures the space filled by an ingredient. Generally refers to liquids. So things like ounces are considered volume measurements, and that's fluid ounces, not weight ounces, which is something different. Weight simply measures the heaviness of an ingredient. And as I just said, the ounce can be either a volume or a weight measure. Water, we're going to talk more about water in the next lecture, but water is the only substance for which volume and weight are equal. Water is a very unusual substance, and again, we're going to talk about why it is so unusual. But as liquids go, it has a lot of properties to it that just make it very different from any other liquid that we know of. So water is the only substance for which volume and weight are equal. So an ounce of water is going to be equal in a weight or as a volume measure. Okay, if that makes sense. Any other liquid, that is not true. Some liquids are more dense, and so they're going to be heavier in their volume weight. So if you were to take let's take another fluid like say gasoline. Okay, obviously gasoline is not safe to eat, and we're not going to be eating that, but it is a liquid that is different from water. So the amount of, if you have 1 fluid ounce of gasoline, it is not going to weigh 1 ounce. The heaviness measure of that gasoline is not going to be equivalent to 1 ounce in weight. Okay? most chefs, when they're cooking, will use weight measurements, and that is because weights are generally more accurate than measuring. In baking recipes in particular, if you've ever gone online and you've seen baking recipes from other countries, because it's really common in Europe and many other countries to do it this way, they might say that you need a certain number of ounces of flour or a certain number of grams of butter. Of course, gram is a metric measure. Whereas here in the United States, we are going to say, a tablespoon of butter or a cup of flour. So it's a little bit different. But the thing about the weights being more accurate is that the weight is the weight. And by that I mean that depending on, and we're going to see this in lab when we do this, the weighing exercise, but a cup of flour can have different weights depending on a lot of things. Has the flour been really packed in? Are there a lot of air pockets? Is it sifted beforehand? Really what you're asking is how much air in addition to flour is in that cup. And so we can have two different groups measure out a cup of flour, which is what we will do in the lab, and you'll find that those same cups of flour that are in the measuring cup can have very, very different weights, and that's because of density. The more dense something is, the more it's going to weigh. But in a recipe calling for 100 grams of flour, 100 grams is 100 grams. It's always going to be 100 grams. It's not relying on that cup measure. So using weight for ingredients turns out products that are much more consistent. And as I said, in many parts of the world, that's the norm. Some standard U.S. measures that you may be familiar with. These are things that if you cook at all, and certainly in this class you're going to have to know. We've just got some standard volume and weight measures. 1 gallon of liquid equals 4 quarts. 1 quart equals 4 cups. 1 pint equals 2 cups. 1 cup equals 16 tablespoons. 1 tablespoon equals 3 teaspoons. And 1 fluid ounce, remember not the weight ounce, equals 2 tablespoons. Those are really good conversions to know if you're in your kitchen and you're cooking something and you need to know how many teaspoons are in a tablespoon. I find myself using that one all the time. So those are volume, liquid measurements. How much is in a given space. Weight refers to the mass, actually how heavy something is. So we're all familiar with the pound, and as you see on there, 1 pound is equal to 16 ounces. And again, that's the weight, the heaviness ounces, not the fluid ounces. Don't get them confused. They're different, except for water. So we're going to talk a little bit about measuring tools. The tools that we use to measure our ingredients out are really important. And you may not realize how wet and dry ingredients really should be measured out using different utensils. I think most of us at home, we just sort of grab, whatever we have. If something calls for a cup of an ingredient, you just sort of grab whatever is there that is marked as a cup. But actually, different types of measuring equipment is made for different types of foods, mainly whether they're liquid or solid or semi-solid. So the selection of your measuring tools really depends on the ingredient, basically if it's wet or if it's dry, and to some degree how much is needed. So for dry or solid ingredients, these are things like any of your dry ingredients such as flour or salt or baking powder, spices, those sorts of things. You're going to want to use, as you see here in the picture, what we call fractional cups with no pouring lip. Generally, any kind of liquid measuring cup should have a pouring lip on it, so that's kind of a giveaway as to what you use it for. These that you see in the picture have no pouring lip, and so they're actually intended for solid ingredients. If you're measuring out something like shortening, that's also considered something that you wouldn't use a pouring lip for that. You would use a flat-topped fractional cup. So the way that you use those, obviously, is to fill the measuring cup and level at the top. If you've ever made anything with flour, you may have leveled the top off with a knife or another straight edge. For amounts smaller than a quarter cup, you definitely want to use measuring spoons. If it's less than a quarter cup, you're much better off. You're going to get a more accurate measure than trying to eyeball, a level on one of the measuring cups. So 1 tablespoon. So tablespoons, teaspoons, half teaspoons, and quarter teaspoons are also other measures that you're going to use. Liquid ingredients, as I said, are going to require some sort of a cup with a pouring lip. You're also going to want to make sure that your cups with pouring lips are clear, and generally they are. You'll find them made out of glass or plastic, usually. But there's a reason that you need to be able to see in them, and of course that is that you need to see the level of whatever it is that you're pouring in there. Whenever you're measuring out liquid ingredients, your cup has to be on a flat surface for obvious reasons, because you're trying to match up the level. The other thing, though, is that the reading on these liquid cups needs to be done at eye level, because if you're standing above looking down at the cup, that can sort of skew how much you think is actually in there. So get down to eye level, take a look at the numbers and the line and where the top level of your liquid is coming to. Different fluids act different ways in the cup, and this is one of those, what I'm going to talk about now is one of those rules that may sound kind of sort of tedious and you wonder why we're doing it, but remember, this may or may not make a big difference in home cooking, but something that you're going to be much more aware of in institutional cooking or in food production. And what I mean by that is if we take a look at the next thing on the slide where it says water-based liquids read at the bottom of the meniscus, fat-based liquids read at the top of the meniscus. So we'll talk about that in the next slide. More viscous liquids such as honey, you're going to want to use a rubber scraper to make sure you've gotten everything out of there. That's very important. This figure right here, I'm going to explain what we're looking at. So this is obviously a transparent liquid measuring cup with a pouring lip, and you see the 2 circles on either side. And what that's representing is, if you look down toward the surface, those 2 circles are magnifying the top level of the liquid. Okay, the top level of the liquid against the wall of the cup, and you're going to see that darkened area within the circle represents the liquid, and you're going to see that the level comes up to the side a little bit. It curves up. The top of the surface of the liquid is referred to as the meniscus, and the meniscus high point is where that liquid actually curves up against the wall. So that can actually throw you off. It can actually, you can think that you have more liquid in there than you actually do. And the way you get around that is you get down at eye level and you make sure that the top of the meniscus, or the level of the meniscus, is right at whatever line that you want to be. In this case, maybe 200 milliliters. Water-based liquids will pull up on the sides, okay, and that has to do with the hydrogen bonding at the top of the water surface. We'll talk about hydrogen bonding more in the next lecture. Fat-based liquids do exactly the opposite. What they do is instead of that line curving up, the line will curve down. So this is something that you can eliminate by getting way down at eye level and taking a look at the total level of the liquid. Measuring fats is depending on the state of the fats, that's going to really kind of dictate what you need to use. Liquid fats can be measured in liquid equipment, so something with a pouring lip. Solid fats, if it's in a stick form, like butter or margarine, if you look a lot of times on the paper, it will have some sort of a measure there, and it will tell you that if you cut here, it's 1 tablespoon. Typically, 1 regular stick of butter has about 8 tablespoons in it, so you can measure it that way. Solid fats like shortening, for example, you actually need to pack into that fractional cup with the flat top. And the shortening is actually something that we're going to measure out when we are in lab. We're going to be measuring out 1 cup. It's either a cup or a half a cup. We'll have to see when we get in there. I can't remember which one I put. But at any rate, you're going to measure that amount out, and you're going to put it in the fractional cup, and you're going to pack it in there and get it in there the best you can, and then you're going to weigh it. And once again, we're going to see that the class, our different lab groups, are going to have different levels, different weights of shortening, because as with the flour that we talked a little bit about earlier, the problem with solid fats is that they form air bubbles and air pockets within unless you really, really push them down. So this is an example of, if you don't measure those fats out really well and really push that fat in there to get rid of the air pockets, you could end up, say you're making a cake, you could end up with a couple teaspoons less of fat, and that will affect your final outcome on that cake. You may find that it's more tougher than it should be because it doesn't have enough fat in it. At the bottom you see a comment that says, allow solid fats to become plastic at room temperature. Now when I'm using the word plastic here, I'm not talking about actual plastic. What I'm talking about is, this is actually an adjective. When you're talking about fats, plastic means that it is easily moldable. So a solid fat at room temperature is going to be much more easy to mold into a measuring cup than one that's refrigerated. And you can think about this with butter. If you have a stick of butter and you've taken it directly out of the refrigerator and you try to mold it into the inside of a cup, you're going to have all kinds of air pockets, and it's going to be really difficult to mold inside of that cup. However, if that same stick of butter is at room temperature, it's going to be a lot easier to press into the cup and get a much even measure. So solid fats really need to become somewhat soft or plastic before trying to measure them out into cups. Okay, we'll talk about sugars. Sugars have their own issues. In cooking, generally here we'll use granulated, brown, or powdered sugar. Sugars tend to clump up, granulated sugars. One of the things that you want to do is you need to stir them, break up lumps, and just really get that sugar in a pretty uniform granulated form before you measure it out. If you've got a lot of clumps, that can actually increase the density of the amount of sugar that you're using, and again can throw off your recipe. Brown sugar, almost every recipe that you're going to see for brown sugar requires you to pack it into the cup. So these are dry ingredients. We're going to use the fractional flat top cups. So if you're using brown sugar, you're going to spoon it into the cup and then press it and pack it before putting it into your recipe. And if you think about it, if you don't pack it, most recipes are going to tell you that you have to pack that sugar. If you don't do that, you don't pack your brown sugar, the thing that's going to happen is that in terms of density, you're going to be using a lot less brown sugar. than the recipe intended. So your recipe isn't going to turn out right. We're going to see later in the semester, particularly when we talk about baking, the roles of all of the different ingredients in recipes, and fats and sugars and liquids. They all have particular functions that they serve, and they need to be present in certain amounts. And if you don't get this measurement right, your recipe is not going to turn out, or it's not going to turn out as well. Powdered sugar, which is also referred to as confectioner's sugar, should be sifted. And that's because confectioner's sugar has a tendency to kind of clump up, and so you'll have like many little balls of confectioner's sugar in the container, and again, that can throw off your measure if you don't sift it out first and really make the texture of that confectioner's sugar very uniform. Flour presents a particular challenge, and I referred to it in earlier slides, that depending on how you measure flour out, the density can be really different in the cup, which is why, as I said earlier, most professional pastry chefs and cooks will use weight measures when measuring out flour. But the thing about flour itself, much like some of the other foods we talked about, like sugar, is because it's granular in form. Flour in particular packs really well. One of the things that you never ever want to do when you're measuring flour out is tap the bottom of the measuring cup to try to compact it down more. That actually is going to cause you to use more flour in a particular recipe than you need. And so what may happen there is, if you're making a cake, you may end up with something that is just extra tough because it's got too much flour in it, or it's too dry. And you may wonder, well, I don't know why that recipe didn't turn out. I followed the recipe. And you did follow the recipe, but the thing that a recipe is not going to tell you is the technique of measuring things out. And sometimes that can be the difference between a recipe turning out really, really well and then maybe turning out not so well. The ingredients were all the same, but the technique used to measure was not. And so you end up with different results from the same ingredients. The way that you measure flour out is always, always, always to sift it. And that's something that we're going to do in lab. We're going to sift it out. And what sifting does is it really kind of separates out all the particles that make up flour, lets some of the air in, and sort of, I guess for lack of a better term, sort of fluffs them up. And that's what you want, because when recipes are written, that is what is sort of the unwritten expectation, is that you're going to sift that flour out. It also removes any lumps. Like we said with the sugar, that clumping actually can increase the density of sugar that's used and result in more used in the recipe. After flour is sifted, it should always be, you should take a spoon the flour lightly into the cup, and then level it off with your straight edge. Always avoid packing. This really says sort of the same thing I just said before, but again, just to reiterate, white flour is very difficult to measure accurately by volume. Remember, that's by using a cup alone. Tiny particles vary in shape and size, has a tendency to pack. White flours can differ in density. The majority of the flour that we use here in the United States is wheat flour. And as you see here, the density is about 132 grams per cup in wheat flour. As comparison, some of these other flours like soy can actually be a lot less dense. What that means is if you substitute different flours for different recipes, you can end up with widely varying results because the amount of flour is not the same. Also not mentioned here is that different flours act different ways in recipes. So using soy flour for wheat flour, you may not have some of the benefits that, or some of the abilities that wheat flour has, like gluten formation. We're going to talk about that as we go on through the semester. On average, 1 pound of all-purpose flour averages about 4 cups. The exception to the flour sifting rule is actually the whole grain flour. So a whole grain wheat flour, for example, is going to have parts of the bran and the germ in there that if you sift out that type of flour, you're going to remove those items, the bran level, bran content in particular, which is beneficial and is probably the reason that the wheat flour is being used. That's where the fiber comes from. So again, if you sift it, that's all going to come out, and you might as well use all-purpose flour. Whole grain flour is also referred to as graham flour. That's not really a term we hear so much, but just so that you're aware of it, that is just another name for it. One of the other reasons for not having to sift whole wheat flour is the bran itself prevents the flour from compacting down. It really sort of acts as a spacer between the particles. So sifting isn't really needed anyway. So bottom line, if you're using whole grain flours, don't worry about sifting them. Just follow the other steps. Spoon them lightly into cups and then level them off. We're going to change the topic a little bit, switch gears, and we're going to talk about knife skills. In this class, you're going to be handling knives, and I wanted to say a few words about knife safety because I'm not interested in anybody getting hurt in class. So I'm going to go over a few things here. First of all, whenever you're walking with a knife, a couple basic rules. All of the knives in the lab have cardboard sheaths on them, and so what I would prefer is that you walk with the sheath on so that the sharpened edges are not out and potentially able to hurt somebody. However, if you don't have the sheath and you're just walking somewhere and you need to have your knife with you for whatever reason, what you're going to do is you're going to hold it down alongside your leg with the tip down and the edge facing away from the direction you're walking. So the sharp edge is going to be facing in back of you. And again, that's just to prevent if somebody runs into you, you're not going to stab them. I haven't had any stabbings in class yet, so let's try to keep it that way. Also important to remember that knives should always be sharpened. Now in class, you don't really need to worry about that. We take care of that for you. But if you have knives at home, it's worth it to make sure that that they are sharpened. And we're going to talk about how to sharpen your knives. Problem with dull knives is that they slip more easily when you're cutting something. It's more likely that they're going to slip and cut you. And the sharper a knife is, the easier it's going to be for that knife to actually just bite into the food and not slip at all. You want to make sure that you're not putting your knives carelessly down in places where others might be unaware of them or go to grab them. This is particularly important when you are washing them in the kitchen. Something that you never ever want to do is take a sharp knife and put it into a sink submerged in water. That would be very easy for somebody to come in and grab something out of the sink and end up cutting themselves very badly. I've seen this happen, and it can be pretty gruesome. So you always want to make sure that when you place your knives down, they are either sheathed or everybody is aware that it's right there. Put it on the cutting board. Don't put them down on chairs. Don't do anything like that. If you're going to hand a knife to someone else, you can again make sure that it has a sheath on it, or you can simply place the knife down on the table and let the other person pick it up rather than actually handing it to them, unless of course you're offering them the handle side, and then that would be okay. But Again, I want you all to be really, really careful with handling knives in the class, just so we don't have any inadvertent injuries. So some of the parts of the knife, as you see here, some are kind of obvious, such as the blade. The blade has different cutting surfaces, the very tip, the mid part of the knife, and the bottom. As we travel down the knife, you can see that the bolster is the point where the blade meets the handle. Many times it's a thicker piece of metal, not always, but on more expensive knives it's a thicker piece of metal, which adds balance to the knife. As we go down, we see the handle. Handles are made of a lot of different materials: plastic, wood, composite materials. Obviously, the more expensive the knife, the more high quality the handle is going to be. Rivets to places where the knife is actually bolted into the handle. Not all knives have that. In more expensive knives, what you're going to see is in the handle itself is going to be split by the metal of the blade coming down into the handle where it's secured by those rivets. And then at the very bottom you have the tang, which is really sort of where the pinky finger rests. And it just kind of curves around, so it's really more for handling. The more expensive the knife, the heavier it's generally going to be. And heavier knives actually help you control them a little bit better. If your knife has a bit of heft to it, it's ultimately going to be easier for you to handle and will do a better job. You know, one of the things that a heavier knife will do is it'll actually help you do the slicing, because you don't have to exert as much force if the knife is heavier. Sharpening of knives is very important. More inexpensive knives, really, really cheap knives that aren't very heavyweight or just sort of stamped metal, those may not be worth sharpening. Sometimes the metal is just really thin. What I suggest is spending, if you are interested in having a good knife, spend money on the best knife you can afford. And we'll talk about which knives, if you're only able to afford a couple of knives in your kitchen, which ones are the best ones to get. But more expensive knives are repeatedly sharpened. And we'll talk more about that in lab, but sharpening is done with something called a sharpening stone. It's also referred to as a whetstone. And these stones they're sort of like different grits of sandpaper. You have sandpapers that are really, really coarse, and then depending on the type of work that you're doing, they become less and less coarse until they can actually become very fine. And the finer the sandpaper, the finer the stone, the more fine the sharpening is. Generally, if the side of the stone that you're using is very coarse, coarse stones are what you want to use when you start to sharpen your knife, because it takes the most metal off of your knife, which is what you want when you're sharpening it. And then as your knife gets sharper, you can move it to a finer grit. Your knife will lose metal as you sharpen it, and chefs who have knives that they've had for many, many years, that chef knife can be significantly thinner if they've had a knife for many decades. It can be much thinner than it was when they first got it, because over the years of sharpening, it's worn off more and more metal in an effort to keep that edge. I suppose it's sort of like sharpening a pencil. You start with a long pencil, and as you sharpen it and you use it, the pencil gets shorter and shorter. And the same can be said for these high quality knives. Sharpening should be done pretty frequently to keep that knife in good shape, and to keep it safe. As I said, a sharp knife is a safe knife. When you're sharpening, you want to hold the knife to a 20-degree angle, and really what you're doing is you're sort of swiping it across the knife, swiping the knife across the stone. And we'll do a demonstration of this so that you can see what I'm talking about. Whetstones use some sort of a lubricant. That lubricant can actually be just water, or some people prefer to use mineral oil. Personally, I prefer water, just because it doesn't gum up my stone, and it dries out and keeps the stone in pretty good shape. So that's just my personal preference. Electric sharpeners, I generally recommend that people sort of avoid those unless they really know what they're doing. Over sharpening your knife is something that can wear off more metal. Then you should have it sort of the same. If we go back to the pencil analogy, it's sort of like sharpening your pencil to the point where it's so sharp it can't be sharpened anymore, and then the lead breaks off and you have to start all over again. You can really damage a knife by over sharpening, or frankly not knowing what you're doing. I've seen the edges of knives that have been really messed up by somebody who doesn't know what they're doing on an electric sharpener. So just a word of advice. If you do want your knives professionally sharpened and you don't want to do it yourself, I know that a lot of butchers or grocery store meat departments will do that for you. So sometimes you can just take your knives for free, and they'll go ahead and take care of that for you. Part of sharpening your knives involves doing something called honing. And as you see in the picture, there is the long metal piece that's not the knife, and in the picture the man is dragging the knife along the edge of it there. That's actually something called a steel, and you may be familiar with what that is. I think a lot of people think that performing this action actually sharpens the knife, and that's not the intention of the steel. What the steel does is it hones or further perfects a sharpened blade. The other thing that it does, as I mentioned in the previous slide, is when you're sharpening, you're losing metal. You're actually scraping metal, the dull metal, off the side so you can refresh the blade underneath. The steel itself is magnetic, and so as the knife is dragged back and forth across the steel, it magnetizes and pulls off that extra metal. So the purpose is, as you see on the slide here, it maintains the edge, but it does not sharpen the knife. As with sharpening, and I think I didn't mention this in the last slide, but when you're sharpening, you need to be very careful that the entire blade is dragged across the whetstone. Just as you here need to make sure the entire blade is dragged across the steel. And you need to make sure that both sides of the knife are dragged the same number of times, so you don't have one side that's sharper than the other. Some people use the steel, as you see here, by putting the pointed end down on a surface and dragging the knife back and forth across. Others will hold it with the tip side up and do it that way. There's really no right or wrong way to do that. It's just more a matter of what you feel comfortable with. On this slide, I've got some basic types of knives. Depending on how into cooking you are, can sort of dictate the types of knives that you have. There are a lot of them out there. A lot of them are specialty knives. In different kitchens, if people specialize in particular types of cooking, they may have knives that are designed for that. Like Asian cooking, there are a lot of special Asian type knives to produce cuts of meat and vegetables that are for particular types of dishes. But if you're a home cook, there's really only I would say two types, and actually probably a third type that are most important to have. You don't have to have a big, huge knife collection if you want to, be a good cook. The first type that you should have is listed there at the top. That's the chef's knife. Chef's knives come in different lengths. For most home kitchens, an 8-inch chef's knife is more than adequate for what you would need. As I said previously, you want to buy one that has a bit of weight to it, and it has good balance in your hand. It feels good in your hand when you hold it. So that's the chef knife at the top. The next knife that is really important to have in your kitchen is some sort of a paring knife. And that's the smaller knife that you see below. Most paring knives are 2 to 3 inches long. Again, you want to buy the best one that you can afford. And paring knife is obviously for smaller work, for cutting things that the chef's knife is really too large to cut. Although when you're cutting with a chef's knife, you can do some delicate cutting up toward the tip and use it in place of a paring knife, but unless you're really skilled, a paring knife tends to work a little better for that. The third type of knife that is really beneficial to have is the serrated knife, the one that I have there that has bread and tomatoes underneath it. This is also called a bread knife, and you can see that it's got that serrated edge, and the end of a bread knife does not end in a point. It rather comes down as a curve, as you see there. And this is really handy for bread, obviously, but also really thin-skinned vegetables such as tomatoes. It works really well on tomatoes. So if you have no other knives in your kitchen, those three are great. I highly recommend them. There are many, many more knives than I have listed on this page, but some of the other ones that, depending on the level of cooking and food prep that you do, boning knife, as you see there, is a very thin blade, and it kind of comes out on the end. That's for just what it sounds like. It's for boning, taking bones off of chicken or beef or pork or those things. If you do that, that's what butchers use if they're cutting things by hand. That is the type of knife that they will use. There's another type of knife called a fish knife, which actually looks a lot like the one below, the utility knife, but the blade is flexible. You can actually bend it back and forth, and that is for separating the meat of a fish from the bones. Utility knife, they're sort of an all-around type knife. It's sort of a medium length. It's something that can sort of fill in a bunch of different places. Straight edge knives, that is a slicer. This is actually a very long knife. Again, not something that you would typically need for household purposes. Okay, so we're going to talk about how to hold a knife. And many times when I ask people to cut something for me, and it's something I'm actually going to be doing when you all are cutting vegetables and so forth, I'm going to be walking around and taking a look at how you're handling your knives. Many people who don't have any sort of culinary training, I find, will cut with their middle finger and their thumb gripping the blade and their index finger resting on the spine of the blade. And that's fine for if you're doing a little bit of cutting. If you're doing a lot of cutting, that's going to tire your hand out really easily. The other problem with it is that you don't have as much control over the blade as if you use something called the pinch grip. And this is something that we use with the chef's knife. So on a chef's knife, what you're going to do, and I'll show you a picture in the next slide here, but to describe it to you, the pinch grip is really what you have your thumb on one side of the blade and your index finger on the other side of the blade sort of curled around, so that the blade, the lower part of the blade, is pinched between your index finger and your thumb. and your remaining 3 fingers are curled around the handle of the knife. It keeps your hand from getting tired if you have a lot of slicing to do. And as I said, most importantly, is it increases your control and your grip on that knife. So it's safer to handle it that way. Light tasks, we talked about the different parts of the edge of the blade. The very tip can be used like a paring knife. It can be done very delicate work if you need to do something like slicing strawberries or something like that. There's not as much pressure on the end, the tip of the chef's knife. For harder tasks or food that is harder to slice, actually slicing down using the base of the knife down closer to where your hand is going to allow you to exert more pressure on the food. So it actually can make slicing tougher things easier. That's not something you would do with the blade of the knife. And on this slide you can see what the pinch grip actually looks like. So you've got your thumb on one side, your curled index finger, your last 3 fingers curled around the grip, and this is how you're going to use your chef's knife. This doesn't work on the smaller knives like the paring knife or even the bread knife or the thinner bladed knives, but the chef's knife, this is what works, and this is how you should hold it. All right, we're going to talk about how to cut certain foods as well, and if you look in the picture up there, you're going to see this person's hand is holding what looks like a potato, and the knife is going through the end. The hand that's holding the food, not the cutting hand, but the other hand, is referred to as the guiding hand. And so that hand is holding the food in place. And you see that the fingers are curled down so that they are not sticking out where the knife can cut it. You're going to be moving your guide hand back as you slice through the food with the knife. And we'll do the demo in lab so you can see exactly what I'm talking about, but these are the basic mechanics. This is what we just talked about earlier, the tip, again, using the chef knife, tip for delicate, tender work, the center of the blade for all-purpose work. There's a little more pressure in that center part of the blade, but not as much as at the heel. And the heel is going to do the heavier work, the food that's a little bit more resistant. It's one of the reasons why the chef's knives are so versatile, and why, as I said, if you have no other knife in your kitchen, this is the one that you want to have. When we're cutting foods, one of the most important things that you should keep in mind is the uniformity of the cuts that you're making. When you're cutting vegetables that are going to be cooked, it's important that the uniform size is important, because if you're going to cook these things, obviously larger pieces of food are not going to cook as well and as evenly as smaller pieces of food. So if you have, let's just say carrots for example, if you're not cutting them uniformly, you're going to have a mix of mushy carrots and carrots that didn't cook enough. So that's important to consider. With raw vegetables, it's not as much of a concern. If you're doing salads, it's not as much of a concern. But anytime that you have anything that's going to be cooked, it is important to keep that in mind. On here, we have some of the different types of cuts that we produce. These are basic. There certainly is not an all-inclusive list, but the basic types of cuts, including slicing, and I've got pictures of this in the next couple of slides. Slicing is really where the tip of the blade stays on your cutting board while the food is moved under the blade as it's sliced, and that was kind of what we saw in the previous slide with the guide hand moving the food through. Julienne cut is where the food is cut into what resembles matchsticks, and there are different sizes of sticks you can cut the food into. Shredding, dicing, or cubing. many times with dice or cube, traditionally a food would be cut into a julienne first. So say we're working with potatoes or carrots or something, then those sticks would be cut into dices or cubes. Mince is meaning to chop food into very, very fine pieces. Something like garlic is many times going to be cut in very fine pieces to be added to your recipe. And peeling, simply removing the skin of a fruit or a vegetable. This is the slice that I was talking about earlier. You've got, and actually it cracks me up in this picture because in the first picture he's holding his knife wrong. Don't do that. Don't put your fingertip on the spine of the knife. These are not my hands, by the way. So, but if we can ignore that, we can see that we're starting with the blade tip down, slicing through the mushroom. The tip of the knife is actually on the cutting board. It's staying on the cutting board as we slice down, and then you just simply lift it up again, and you go on forward. The guide hand is pushing the food on through. This is something that if you've ever seen a chef work, or you've seen somebody who thinks they know what they're doing and they're chopping like a maniac. They may actually know what they're doing if they're doing it regularly. And if you're a prep cook and you chop, hundreds of pounds of vegetables every day, then those guys and girls know what they're doing, and can really do some fine cutting very quickly. Most of us mortals, however, need to take our time with this. So please, when you're in lab, take your time. And pay attention to what you're cutting, because I'm not interested in having any severed appendages in anything that we are cooking. Here you can see some of the stick cuts, and you see the picture of the carrot here. In classic French cooking, the different cuts have established dimensions. A fine julienne, as you see there, is a matchstick that is 1/16 of an inch by 1/16 of an inch, and it's about 1 to 2 inches long. When I was in culinary school, we actually were given rulers, and we had to measure these out and measure 1/16 by 1/16. So you all are not in culinary school, so I'm not going to expect that level of work from you here, unless you want to. But in classic French cooking, that is something that can be very important, because it's for appearance, and it's for how the food acts under cooking, the different sizes, and the amount of heat and the time that you put to it can produce the desired product. So it really can be sort of a science. A traditional julienne is 1/8 of an inch by 1/8 of an inch by 1 to 2 inches. So that means 1 to 2 inches long. Traditionally, the rule with how long a julienne should be is you don't really want it to be any longer than would rest comfortably across a soup spoon. And the thinking on that is that if you went to put a bite of a soup, say, for example, in your mouth, you wouldn't want, half your carrot hanging out. So you wouldn't want it so long that it wouldn't fit into your mouth comfortably. Another stick cut that it looks like a julienne, but it's actually a thicker julienne. That's called a bâtonnet, and that is 1/4 inch by 1/4 inch, and about 2 to 2.5 inches long. Bâtonnets, or the stick cuts, as I said in the previous slide, can be cut into cubes. And so if you cut that, let's just say the bâtonnet, if you cut those sticks into cubes that are 1/4 inch long, you're going to have what's referred to as a small dice. Chopped juliennes are referred to as a brunoise, and that is a French term. I'm going to do a demo cutting an onion in class, so you can see how that goes, but it's actually very easy to cut an onion into a dice, and you will also be doing that in lab, so you'll get a chance to slice up an onion. Onions are very commonly used in all different types of cuisine across the world. Virtually every cultural cuisine uses onion. And so if you're anybody who cooks very regularly, you probably are chopping your fair share of onions. So this is a really a good trick to know. Essentially, you're cutting vertical all the way through the onion, and then you're going to make some additional vertical cuts. And it's hard to describe how this is done, so I'll again be demonstrating it in lab so you can take a look and see how it's done. Knife care is really important, especially if your knives are very expensive. You want to take care of them. Knives should always be cleaned immediately after use to help extend their life and to prevent rust. It's very important. So, food, if it's left on the blade of the knife, can, depending on what the knife is made of, it can cause corrosion and rusting. So you want to clean them up immediately. You never ever should put good knives in the washing machine, or I'm sorry, the dishwasher. I hope you wouldn't put them in the washing machine, but we're talking about the dishwasher here. And the reason for that is that dishwashing detergents can be a little bit harsh and can break down the handles many times. There's a potential for the blades to knock around into other things that are in the dishwasher, which can cause dulling of the knives. There's also, of course, the danger of having knives laying around in the dishwashing machine when it comes time to put other things away. And any prolonged exposure to high heat can cause damage to not only the handle but the integrity, where there are rivets, and just really can make the overall structure of the knife weaker. So it's always best to wash your blades by hand. That said, as I mentioned earlier, you never ever want to put knives into a sink that maybe has soap suds on top, or other things in the sink that may obscure the knife. That's a safety hazard. It's always best to wash knives immediately, or just set them on the side of the sink where they're visible, so that nobody gets injured. And you always want to make sure that your knives are stored in such a way that they're protected from damage. And many times that can take the form of special knife drawers, where the knife blades have slots to insert the knives into, or you can store them on magnetized blades, magnetized strips. This is actually what I have in my house. I've got magnetized strips on my kitchen wall, and I just put the knives on those so they're out of reach, but the blades aren't touching. And then some people like to sheathe them, and this is what we do here in class. You're going to be washing your knives and sheathing them back into the cardboard before we put them into storage, and that will protect them and us.